So for, yes. The left light, yeah, that's fine. So for our warm-up, we're identifying the value of our missing angles. So we have angle A, angle B, and angle C. If we start off with angle A belongs in this cluster of angles. So you want to compare angle A with a known angle measurement. So the only known angle measurement we have is 125. So what relationship do angle A and 125 degrees have, Mason? They're supplementary, okay, which means that when we add them together, it's going to equal 180 degrees. So angle A and then the 125 degrees are supplementary. You guys need to make sure you not only know how to find your missing measurements, but you also know how to indicate the relationship that's involved with those measurements. So these angles right here are forming that supplementary pair. So that means that if we take angle A and we add it with 125, it's going to be equal to 180 degrees. All we have to do to solve is to subtract 125 from both sides. Okay, and then you guys should have got that angle A is going to be equal to 55 degrees. Okay, so knowing angle A is equal to 55 degrees, we can go ahead and move on. Let's take a look at B, angle B. Again, angle B, and the only measurement that we know is 125. What relationship do angle B and angle 125 have, James? They're not supplementary, no. Anybody else besides Mason? Caleb? They're vertical. And what does vertical mean again? They're congruent. They're the same, right? So these measurements are going to be the same with each other because they're directly across from each other. They are vertical angles. So angle B and then 125 degrees are vertical. So they are equal to each other. So angle B is equal to 125. Okay, and then angle C is a part of a different cluster. So we don't use this information at all. This information is not necessary in order to be able to solve for angle C. So what relationship can we relate in this situation? There's actually two relationships that you can create in this situation, but what's one of the relationships that we automatically can see here? Somebody besides the people who've answered. Okay, Kingsley. Okay, complementary with what angle? With the 60 and C, right? 60 and C are complementary, but you could also say supplementary because 60, C, and this 90-degree angle are forming a supplementary pair. So you could have said that they are supplementary if you involved all three angles, or you could just focus on the complementary pair, which is formed right here with the 60 degrees in the C. So angle C and 60 degrees are complementary. Okay, that means that angle C plus 60 is going to equal to 90 degrees. And again, all we would have to do in this case is just to subtract the 60. And we would get that angle C is going to be equal to 30 degrees. Okay, and then we're done. All right, problem number 2, we want to know the parallel cross-section of a trapezoidal prism. Parallel cross-section of a trapezoidal prism. Okay, so there's a couple of things that are being indicated to us. We're told that it's a parallel cross-section. Remember, if it is parallel, then it does not touch the base. If it's parallel, it does not touch the base at all. We also have an indication of the fact that the trapezoidal prism means that the base is a trapezoid and that the faces, the remaining faces, are all going to be rectangles because we're talking about a prism. Okay, so if you actually wanted to see that visually, you could just draw a trapezoid and then draw kind of like a similar trapezoid underneath it. And then connect. Okay, so then we have our trapezoidal prism. It's not the best picture in the world, but it still will manage. Okay, and then parallel cross-section means, again, it's not going to touch the base, so it's just going to go in this direction right here. So if we were to do that cross-section, then what shape would we get? Trapezoid, right? You pull it apart, you're just going to get a trapezoid. Okay, and then what cross-section will you get no matter how you slice a sphere? No matter what we do with a sphere, we will always get what? Circles. Okay, it does not matter how you slice that sphere, you're always going to indicate a circle for the cross-section. All right, and then for our last problem, it's focusing back on information that you guys learned last semester, but it is something that you need to make sure that you have an understanding of for your milestones, and it was a concept that you guys were weakest in, so I want to make sure that we're covering that concept real quickly. So remember when we talked about similar triangles and how they relate to slope in a graph? When we go through this, what we want to do is we want to make sure that we read through every single one of these statements and see whether it is true or false, because we're trying to identify all possible true statements. That means that there are more than one true statements here. So if we're taking a look here, we're given a line, and then we're given several triangles, similar triangles, that are indicating a rise and a run of that line. And remember, on a given line, it doesn't matter which points you choose on the line, the slope is always going to be the same. So if I choose points A to D, it's the same slope as choosing point A to B, or B to C, or C to D, or B to D, or A to C. You know, you have all these possibilities, but they're all going to simplify to the exact same slope. So we're wanting to know which statements are going to relate that information. So the first statement says that the slope of AC is equal to the slope of FD. So I'm going to use my highlighters to indicate what those look like real quick. So if we're talking about slope of AC, so from A to C, that's located right here. From point A to point C, that's a line. And they're stating that it's going to be the exact same thing as the slope of FD. So FD is located right there. Are those the same slopes? No. One of them is a positive slope and the other one is a zero slope. So they are definitely not the same. So this statement is false. I can go ahead and cross that one off. All right, the slope of AC, all right, I already identified AC in my pink, so I'm going to highlight that in pink again, is equal to the slope of BD. I'm going to do that in a different color. I'm going to put BD in blue. Okay, so here's where B is and here's where D is. Are those slopes going to be the same? Yes, because why? They're on the same line. They are on the same line. They are the same line. So their slope is going to be identical to each other. So this is a true statement. All right, the slope of AC, we're using that pink one again, is equal to the slope of the entire line. Is that true? Is the slope of a portion of the line similar to the slope of the whole line? Guys, come on, I just got done saying that the slope is the same no matter what points you pick. So is the slope the same? Yes. Shh. Those of you keep saying no when I say it doesn't matter where you pick your points on that line, it's the same no matter what. There are points that extend beyond what we see here. It is the same no matter what. Slope on a line is the same no matter what points you pick. Okay, because it's talking about steepness. You guys do realize that. Slope is an indication of steepness. So if your line is staying straight, does your steepness ever change? No, your incline is still the same. That's what slope is, how steep your line is. Your line is not changing directions. It's going in the same direction the entire time in a straight pattern, so slope will never change. So this is a true statement. Okay, it's the same thing no matter what for the whole entire line. All right, problem D. The slope of the line is equal to AE over EC. So if we're talking about slope of a line, then we're talking about a rise over a run. So what I want to know is this representing a rise over a run. So we're going to take a look at the AE situation. AE is located right here. Is that a rise? Yeah, that's a rise. And then EC. EC needs to represent a run then if this is truly going to be the slope. And not only any run, it has to be the run on the same exact triangle. So EC happens to be located right here. Is that a run? Yeah. Is it on the same triangle? Yes. So this is a run and it exists on the exact same triangle. That is a true statement. Okay, next one. The slope of the line is equal to EC over FD. Well, we just said EC was a run. Is run allowed to be on top? No, run's not allowed to be on top. And we already identified FD. FD is also a run. So is it going to be run over run? No, can't be run over run. That's not a true statement. Okay, the slope of the line is equal to BF over FD. BF over FD. So here's where BF is located. Is BF a rise? Yep, that's a rise. And then FD, we already identified FD as a run. So now, are they the same rise over run on the exact same triangle? Is this a rise over run on the same triangle? Yeah. So this is a true statement. Okay. So your true statements are B, C, D, and F. We're going to do more practice problems like that again as we're going through. I want to make sure you guys have a good understanding of that. All right. Let's move on to our Part B of our geometry unit. Part B for geometry unit is going to cover circles. So we're actually going to spend the next 3 days, today, tomorrow, and Wednesday, working with circles. And then Thursday and Friday this week, you will focus on surface area. And then next week on Tuesday, you guys are going to have your Part B test. Okay, so it goes pretty quickly. That's why we split it up into 3 sections. So instead of having one massive test that's covering all of geometry, which is a lot of material, we're splitting it up into 3 sections. After we're done with the test, then we're going to focus on interims, okay? Because we'll have covered every bit of information that will present itself on your interims. All right, so for today's focus with circles, we are able to solve for circumference and area of any given circle. And you're going to have to be able to work backwards using circumference or area to solve for a missing part of the circle. So let's first focus on the parts of the circle. You guys were supposed to do a prodigy assignment last week after you were done with your test that went over parts of the circle. So the first part of the circle that we're going to talk about is the radius. So the radius is the length from the center of the circle to any point on the circle. So starting from the center, going to any point on the circle, that's called the radius. And that can exist anywhere. I just happen to draw it here, but I could draw it straight up. I could draw it straight to the left. I could draw it at a diagonal. You have an infinite possibilities of radii that exist on a circle. Okay, then we have our diameter. And our diameter is basically the same measurement as the radius times 2. Because your diameter is your longest stretch from one part of the circle to another part of the circle as long as it passes through your center. Okay, so if I start here and stretch all the way across, that's considered to be the diameter. It is your longest measurement on the inside of the circle. Okay, and again, 2 radii is equivalent to 1 diameter. 1 diameter is equivalent to, half of a diameter is equivalent to 1 radius. Okay, so that's where we got these informations or these formulas right here. That if we wanted to solve for the diameter, all we would have to do is take the radius and multiply it by 2. And if we wanted to solve for the radius, all we would have to do is take the diameter and divide it by 2. Okay, then the last measurement that is a part of the circle that we're going to discuss is the circumference. Now, circumference is very similar to what you guys know as perimeter. Perimeter belongs to polygons. Polygons are shapes with edges, closed shapes with edges and vertices. A circle does not have any edge or vertice, so that's why we don't call it a perimeter, we call it circumference. But it's still the exact same idea. It's the distance that you can wrap around the shape. So going around the circle, that is our circumference. Okay. And then we have our formulas that utilize the radius and the diameter in order to solve for circumference or area of your circle. So our circumference formula is going to relate back to the diameter. So you also need to know this very important little symbol right here. Who can tell me what this symbol is called? James. Pi, right? That symbol is going to be our symbol for pi. And pi, in this case, just so you guys know, I want you to write this down too. Pi is approximately 3.14 or 22 over 7. We tend to use 22 over 7 if we are dealing with values that are divisible by 7 or other fractional values for the radius or diameter. So if they give you a fraction value for your radius or diameter, you probably want to use the fraction value of pi. If they give you a whole number for your radius or the diameter, and that whole number happens to be divisible by 7, okay, it's a multiple of 7, then you want to use 22 over 7, because then you're going to be working with whole numbers instead of decimals. Any other value, 3.14. And then, of course, as always, they'll tell you sometimes, hey, use 3.14 or use 22 over 7. Or they'll tell you to keep it in terms of pi, meaning that you would just say, it's my diameter, and then the pi symbol, instead of actually multiplying by 3.14 or 22 over 7. Okay? So there's our circumference formula. Then we've got our area formula. For area, you are only able to use the radius. And not just the radius, but radius squared. And then you get multiplied by pi. Please keep in mind again that radius squared is not the same thing as radius times 2. Radius squared is radius times radius. That is the biggest mistake in this unit that I see every single year, is that students look at it and go, oh, the radius is 3, so I'm going to do 6 times pi. No, 6 times pi would be the circumference, not the area. You would have to do 9 times pi, because 3 squared is 9, not 6. So be very, very careful about that. All right, so we're going to take a look at a couple of examples here. Given either a diameter or a radius, you want to be able to identify the circumference and or area. Okay, so for this first example, the measurement that's been provided to us is what? The diameter. Okay, so I'm going to go ahead and highlight that and indicate that this is my diameter. So then I'm going to make sure that I note that the diameter is equal to 20, and that when I'm plugging it into my formula is circumference is equal to diameter times pi. And in this situation, with diameter being 20, I can do 20 times 3.14. You're just substituting your value for your diameter and your value for pi into the problem. So now if they said leave it in terms of pi, you would just say, oh, circumference is 20 pi. But I'm not saying to do it in terms of pi. I want to know the actual value, and I want to round it if necessary. We're going to keep it into the 100th place value if needed. But if we do 20 times 3.14, we're just going to get 62.8. Now don't forget to put units of measure. When we're talking about shapes and measurements, you must put your unit of measure. So circumference is in inches here. Now, using the exact same shape, the exact same dimensions that were provided to us, so this again is my diameter. My area formula is focusing, ooh, where's my purple? Oh, there it is. Okay, my area formula again is going to be focusing on taking the radius, squaring it, and then multiplying that value by pi. You must do the exponent first before you can multiply by pi. So we know that diameter in this case is equal to 20. What does that make the radius equal to? 10. The radius is going to be equal to 10 because radius is just half of our diameter. Okay, so we would do 20 divided by 2. Okay, so now plugging that in, that means that we are going to do 10 squared, and then we're going to multiply that by pi. What is 10 squared? 100. So we're going to do 100 times 3.14. So our area in this case is going to be equal to 314, and this is inches squared. Area is always a squared unit. Circumference is a single measure. Okay, single unit of measure. Area is a squared unit of measure. Volume is a cubic unit of measure. Okay, I want you guys to now look at problem below it. In this case, these are not diameters. This is the radius. So we're dealing with a different set, but it's still the same concept, still the same formulas that we're going to be focusing on for here. When we're doing the circumference, I need to make note of the fact that the radius in this case is equal to 9. So that means that the diameter is going to be double the radius. So I'm going to take the radius and multiply it by 2. So my diameter is going to equal 18. Once I know my diameter, I can then go ahead and plug it into my formula where I take the diameter and multiply it by pi. So that means I'm going to do 18, and I'm going to multiply it by 3.14. So my circumference will equal 56.52, and that is yards. When solving for the area, I only need to know what the radius was to be able to substitute it back in for the area formula. So that means I'm going to take my area formula, which is A equals R squared times pi, and then substitute. Since R was a 9, I now have 9 squared times 3.14. And Jamez just made a common mistake, right? 9 squared is not 18, it's 81. Okay, so be careful. That is a common mistake that everybody makes. Thank you for making that mistake because I like to point it out. Okay, so we have 81, not 18. 81 times 3.14, and that will give us our area. Area is going to be equal to 254.34, and again, it's area, so it's yards squared. Don't forget to put the squared at the end of your unit of measure. Okay, what I want you guys to do is you're going to flip it on over to the next page. Front and back, you've got 4 problems. You're going to identify what you're trying to find, what is the formula for what you're trying to find, what measurement do you need from that formula, so do you need the radius or do you need the diameter? Okay, is that measurement given straight to you? Like, did they directly give you the radius, or did they directly give you the diameter? If not, then what do you need to do to find the radius or the diameter that's needed, and then solve for your area or circumference that it's asking. All right, let's go ahead and go over this. So for problem number 1, what is it that we are trying to solve for? The area, right? We are trying to solve for the area. Okay, that's what it's asking for. So the formula for area is going to be r squared times pi, right? Pi r squared times pi, whichever order you want to say it. Okay, so what information do we need to know in order to be able to solve? The radius. We need to know what the radius is going to be. Is that given to us directly? No, the radius has not been given to us. Okay, so how are we going to solve for the radius? What do we need to do to solve for it? Divide the 5 by 2, right? This information that's right here, this is our diameter. So we need to take the diameter of 5 and we're going to divide it by 2, and that means that the radius is 2.5. So now we know the radius. So we can use that information to substitute it into the formula that we were stating, that r squared times pi formula. Okay, so we have 2.25 squared times 3.14. 2.25 squared is 6.25. And then when we multiply that by 3.14, we're going to get 19.625. Okay, and again, that is centimeters squared. That is our formula for area. Okay. All right, let's take a look at problem 2. Problem 2, what are we trying to solve for? The circumference, right? It says solve for the circumference. Okay, so the questions that you always ask yourself, first the formula. So formula for circumference is to take the diameter and multiply it by pi. So what do we need to know? Diameter. We need the diameter's information. Is that given to us directly? Yeah, the diameter is given to us directly. We already know that it is a 5 because this measurement right here, like we said before, that is our diameter. So we can go straight into substituting it into our formula. So circumference equaling diameter, which is 5 times pi, so times 3.14. Okay, so 5 times 3.14 is 15.7, and that is centimeters. Okay, any questions on those first two problems? Pretty quick, straightforward. I think that big area that most people have concerns with or trouble with is being able to round correctly, so just make sure you do understand your rounding. We'll go over that at the very end today. Take a look at problem 3. Problem 3, what are we looking for? Area. So our formula is r squared times pi. What information do we need to know? Radius. Is that given to us? Yep, they gave us the radius. Radius is going to be equal to 8. This information right here, that is r. Okay, so now all we have to do is substitute it into our formula. So we're going to do r squared, which is 8 squared. 8 squared is equal to 64. And we're going to multiply that by pi. So we're going to multiply 64 by 3.14. And that's going to give us an area of 200.96. And that is meters squared. Okay, problem 5, now we're solving for the what? The circumference. They're asking us to solve for circumference. Okay, so circumference formula is going to take the diameter and multiply it by pi. So we need to know the diameter, but they didn't give us the diameter, did they? They gave us the radius, so what do we need to do? Double the radius, right? We need to take 8 and we're going to multiply it by 2 to get a diameter of 16. Okay, so now that we know what the diameter is, we can substitute it into that formula. We can take the diameter, which is 16, and we can multiply it by pi. So multiply 16 times 3.14, and that's going to come out to 50.24 meters. All right, any questions on these? Okay, so sometimes they're going to give you the circumference or they might give you the area and you have to work backwards from that. So we're going to focus primarily on circumference and working backwards. Knowing that the circumference is equal to diameter times pi, if they were to give us the circumference, then all we have to do is divide it by pi and that would become the diameter. So again, circumference is equal to diameter times pi. Diameter is equal to circumference divided by pi. Those are those literal equations that we had worked on earlier in the year, where you're given multiple variables and you're having to reevaluate it in terms of a different variable. Okay, so it's the same kind of concept. If I'm giving you circumference equaling 32.656 yards, then what is the diameter and then what is the radius? So again, working backwards, we know that diameter is going to be equal to our circumference divided by pi. So that means that we're going to take 32.656 and we're going to divide it by 3.14. And that's going to come out to 10.4 yards. That represents the diameter. Okay, now I'm also being asked for the radius. So if I want the radius and I'm given diameter, what do we have to do? Divide it by 2. So we take the diameter and we divide it by 2. So my diameter of 10.4, I'm going to divide it by 2, and what will the radius be? 5.2. And that is still in yards. Okay, go ahead and do 2 and 3 on your own, please. Okay, for problem number 2, circumference was 56.52 inches. So what's the diameter? What's the diameter, guys? 18. What's the radius? 9. Okay, so here's what we get. Again, you're taking the circumference, you're dividing it by 3.14. 56.52 divided by 3.14 is 18. Then take half of 18 to get your radius, that's 9. What about for problem 3? If the circumference is 77.244, what's the diameter? 24.6. What's the radius? 12.3. Good. So there's the diameter and the radius for those. Again, get onto the delta math. It's going over circumference and area. Please be mindful of rounding. You do not want to get something wrong because you rounded incorrectly.